co-author it. So we've done about 300 of them. And the story that I wrote about jump math still is the #1 story in terms of how it's spread. It's still spreading. It was #1 most read story in the New York Times for a whole month when it came out. It's very unusual. So clearly, this approach is really striking a chord among many, many people. You know, there's so many people that say, you know, the same person who would never say I can't read very well will say, can you do the check for me at the restaurant? I'm not good in math. So there's this thing that lots of people think that they can't do math, they don't have the math gene. And I have a couple of kids in my building that have had that experience. So when I wrote about this, and I don't usually do these kinds of talks as a journalist for various things, but I found the response to this particularly important. And given the importance nationally, I'm very sort of interested in how this idea could take root in the United States, potentially like it has in Canada. So I just want to sort of talk to John, ask John first, just kind of explain the basic idea, principles behind jump math, and then I'll ask Melanie, who's been teaching it, what her experience has been, and then we'll go broadly looking at what this means more broadly for teacher preparation and for national standards and so forth. So, John, why don't you begin?
So I'll be brief, and we'll keep coming back to this, but we call the method of jump math guided discovery. You know, there's a lot of debate now about how to teach, and some people advocate going back to more traditional means, and others pure discovery. And from what we've seen in classrooms, and also from the research that we've looked at, particularly in cognitive science, it seems you need a balance of both. That's really optimal. And this isn't just our opinion. I wrote an article for Scientific American Mind where I summarized some of the research, and that. You know, we discovered a lot of things we do by accident being in classrooms, but it seems to correspond pretty well with some of the research. So one of the things cognitive scientists have found is that lots of kids are suffering from cognitive overload. They're often being asked to do too many things at once and not having enough time to consolidate or practice. So we tried to design a really well scaffolded program where each idea follows naturally from the next, and so that kids can actually have a chance of discovering things and figuring things out for themselves. There's also lots of research suggesting that the psychology of the classroom is very important. So Carol Dweck is a huge hero of ours, and virtually everybody in the U.S.
Does everybody know Carol Dweck?
Yeah, so she wrote a book called Mindset that suggests kids who believe that their success depends on having a gift or an innate talent for something do worse over time than kids who think that they can succeed by struggling and persevering and getting good teaching and so on. And there's a beautiful video of her on our homepage at the Jump Math website. She watched a jump class and suggests that because we keep kids in a zone where they're doing things that look hard but aren't too hard, that would help them develop a growth mindset. And I would say, so I'm not going to go into too much detail now, we'll keep coming back to these things, but I think the third difference with jump is there's research that suggests as early as kindergarten, kids start comparing themselves to each other and deciding who's talented and who isn't in math. And as soon as they make the decision that they're not in the talented group, their brains just stop working. They stop paying attention, engaging, remembering things, you know, excitement, memory is tied to excitement. And if not every kid could do math, or not virtually every kid could do math, then we might just have to settle for these hierarchies. But we think the hierarchies themselves are causing problems, because the easier we make it for kids to compare themselves, the easier it is for them to shut down and stop developing growth mindsets, stop remembering, stop thinking math is fun. And so I think the thing that's really different about jump is we've tried to provide enough scaffolding for teachers so that they can keep kids in a zone where they're all succeeding, but still discovering. So the lessons are a series of challenges and questions. The kids are always figuring things out for themselves, but the important thing is to keep them together, because then you get an audience effect, you get a group effect where everybody's excited about math, and that helps them learn better. So that's a sort of overview of some of the key principles in jump, but we'll go into more detail as we discuss this.
Yeah. There's actually even research from Western Canada that shows that these hierarchies that develop as young as grade 1, the kids at the bottom end of the hierarchy have more sick days. That there's potentially even health effects of being seen by yourself as being sort of at the bottom of the hierarchy. So I've interviewed a lot of teachers about this, and a number of teachers said to me that what I used to teach as one step, what I used to think of as one step, I now see as 7, maybe 10 or 11 micro steps, and all that. So this idea of sort of seeing much more sharply. What's been your experience in the classroom in terms of teaching, and how have you found it?
It's funny what you just said, because I was going to say that same thing. Ordinarily,
you
just don't mind. Ordinarily, you would just start teaching like multiplication. You would just start with the standard algorithm, and this shows you that there's steps. There's a bunch of steps before you actually do the standard algorithm, and we sort of skip over steps A and B and just go right to C, where in the jump math, it takes you through all that, and the kids actually, they find step C by themselves. Like, they discover it on their own. They'll say, oh wait, but can't you just do it this way? Or doesn't this work? And yeah, so it's really great. Their confidence is like, it's so great. There is no real hierarchy in my class when it comes to math. Even the lowest learners, they almost are thriving more so than the higher learners, because they see that I can do step 1. Oh wait, and I can do step 2. So then they feel confident they can tackle any problems. We just took the state test, and they weren't even like frazzled by it at all. I mean, they just sat there. I mean, there was no like breakdown of anxiety or anything like that. They sat there, happily just answering the questions. They have fun. Like when it's math time, they're so happy to have math. Like, I mean, if I like move it on the schedule, they're right away, when is it? What do you mean? Why are you doing that? They really enjoy it, and they have like a competition, but it's a competition not amongst each other. It's almost amongst themselves. Can I solve this problem? They're very excited when they can. And it's really, I've never seen that before. Like, that was just, you always have the kids that come in, I can't do math, and you have their parents who say, well, I can't do math, so, I know they're not going to be good at math. And then right away, I used to be like, don't say that, because that's, they believe it. But,
yeah.
But these children believe they can, and,
yeah.
and so they really, they do.
And so if, how do you know, can you give an example of sort of how you can sort of see how you can take something that a normal person would think of as one step and how that's actually 2 or 3 or 4? Is there some, I don't want to put you on the spot, it might be hard to dig that up, but just to sort of illustrate it or bring it alive, is there?
I have an example I remember that I can do when it comes to me, but so you can defer the question or you can give I'll give you a back.
Good phone a friend.
We're all here. We're all about scaffolding confidence here.
I was just going to say the example with the multiplication, like 2 digits times 2 digits. We first started with the ones, and then there's like a blank spot there, so they would just do the ones, and then they would not do the ones. The ones would already be done for them, and then they would just do the tens, and then put it together, and then it would be the ones and the tens. And something else, like we did fractions or angles, when we first started doing angles. We talked about it as each angle ended up as like a full rotation. And so when I introduced then actual finding it, turning the angles into fractions on the circle, because they had that scaffold of knowing that the angles are going to be a full rotation 360. They knew that the 1/4 of the angle was 90 degrees and that all 4 of them would be 360 degrees.
Oh, I'll ask yours after. So if you could just add one more comment on how what's your experience of being a teacher? I mean, obviously you went into teaching because you like kids,
right.
Like working with kids. So how, at the end of the day, what's your life like now? In some ways, does you have a different feeling about teaching? Or is it still the same, but my math class is better?
It's tough. It gets better every year. It's different in different times of the year. It's different too. Like, so for example, what's fresh in my mind is we just did the standardized tests, and so watching them do that was a sense of pride, and like that I had something to do with that. Like made me feel good. I mean, it goes in spurts, like different. Sometimes you don't see the results, so you feel, you feel bad, what can I do? Can I do more? Like, so when I started here at the school, we didn't have, the Common Core was just sort of new, and we didn't have a program, and it was, to find lessons to keep them engaged, to get the children excited about learning, to make sure they were aligned with the Common Core. It's hard, and so to have an opportunity to have a program that's going to instill this excitement was really, I was happy. Like, that made me feel good, because then I feel like, they're really learning. I feel that. Like, I have students who came in crying because they couldn't do math. I mean, real tears. And this one of my students, and she, I mean, as the year went on, you could just see the growth. And then at the end of the year, she passed the state test with the 4, the highest that you could get. And she was, I mean, you wouldn't have thought that day one. Like, that was not a possibility. And when we saw her score, I mean, I cried. I was really, like, that to me was like success.
That's amazing. Thank you. Jason, we were talking before about some of the curriculum aspects of this, and you had we're interested in. Well, I don't want to take words out of your mouth, but why don't you explain what aspects of Jump you find interesting from your perspective?
Since I was on the writing team for the Common Core, it's always nice to be careful to say I'm not speaking ex cathedra on things that I say, but I will get into what interests me. One thing I wanted to say first is that the world is different now in education because we have a shared vision, expectations, and goals. And one of the things that makes possible is a rational instructional materials market where people make decisions about things based on what works. And one of the things maybe not a lot of people know about John is that he's very committed to research and revision. He talks a lot about finding out what's working, and as a nonprofit publisher, he also uses his power and latitude to learn from what works and what doesn't. And in a world with shared standards, that kind of attitude is extremely valuable. So I want to thank you for that. John and I, most of our conversations are about randomized controlled trials, not about math. But I did actually, the first time, and now I'm putting a face to a name, the first time I heard about Jump was reading your article that you mentioned. And so I went to look at it, and here I'll find the example. So in kindergarten, you want students to be able to know which number is bigger than another number, like 3 and 7. It's easy to think that what you do is you write this scribble, a hieroglyph like a 7 and a hieroglyph 3, and you just demand that the kid tell you which one's bigger. But if you put yourself in the mindset of the child, that symbol is an abstraction of something. And so when I went and looked after reading the article, I saw there were many jumps to get to the point before you're flashing these hieroglyphs in front of the students. And it started off, one jump was, I think there was a gorilla, and there were some bananas on one side, bananas on the other side, and it said, which side does the gorilla want? and so in a way, in a kind of a pre-mathematical way, we began to build the reference for the eventual abstract task. And even kindergartners have to do abstract tasks in math. So I don't know many people who obsessively zoom in on the learning progression the way John does. Then the standards go, they set a pace, which is grade by grade, but within the grade, they depend on people to think about how we get from A to B. And there's a lot of work to be done there in figuring that out. So that was an example of a small jump. And John talked about a continuum between rote instruction and pure discovery. And in a way, those are both straw men. But the standards don't take a position on that kind of thing. They're consistent with different approaches. But to the extent that the standards have ideas in them, we need ways to work with kids on ideas. Math is a discipline of ideas. Having those really small jumps, John also talked about the confidence that comes from making those small jumps successfully. And I believe in that. I think that confidence is really important in math, and math makes cowards of us all. those of us who go into math, and John's a mathematician, we know math is hard for everybody. And to some extent, becoming a mathematician, or a physicist in my case, is a decision to embrace what humiliates you. It's not that it's super easy for us, it's that we have a certain resilience that allows us to keep knocking our head against that wall. So that's a good thing to build in kids. And confidence matters in math in a couple of ways. There are group effects, and John will tell you that his program and any good program is not between the covers of the book, it's in terms of the classroom and the way the way the humans in the system are operating. And so John designs for those kinds of group effects. And so confidence in math, there are almost two flavors of it. One is conceptual, it's like, I get it. That's very motivating. And another is, I can do it. You know, John talked about consolidating and practicing. I'm in a lot of debates about math. They call it the math wars, and I think it's because for every question there's a separate war. And one of them is about, do we need to practice, or is that drill and kill? These are all, you know, the middle ground is and artful balances are often, I think, the way to go.
I'd like to add something.
Yeah, sure.
You know, as a not-for-profit, and we have a phenomenal group of writers who are real perfectionists, and all, even our layout team is worried about the details because they actually have an impact. But we've constantly learned, so I believe that the Common Core standards are a real treasure. Most of our writers are mathematicians with education backgrounds, and we were so impressed when we started working on the standards, and the progressions documents are fantastic. So we've learned things from those documents, and I'm going to demonstrate one of them today in my lessons. You know, when kids have an improper fraction like 7/5, and you're trying to get them to change that into a mixed form, so I'll see if I can do it. It would be 1 2/5, I guess. You can do that with pictures and so on, and that works, but I learned something from the Common Core that I'm going to do today. You can actually get kids decomposing fractions into different sums. And so, you know, you could write 7/5 is 5/5 plus 2/5. And I find that's actually a better way than some of the ways we were using before. So I'm going to test that out today in the demo lesson.
Let us know.
Yes, well, if you want to watch it. I don't know if you have to go. But, you know, I think that the U.S. may not recognize it has such a spectacular foundation for mathematics, and we can tell you that coming from Canada. It's a spectacular foundation, and I think you guys should be taking advantage of it. And we think our books are strong, really strong, because our U.S. books are really strong because of the standards. And we just did a pilot in Spain where they used our books in translation, and we're quite happy to, because they thought the standards were so good.
Yeah,
I just wanted to add about the books, because the jump math books, there's no frills, there's no pictures and colors and graphics, they're just the math. And that, I think, is so important, because you have children who are looking for any excuse to not listen and to look at something else. So it really keeps the children focused on what the lesson is.
Yeah, and there is quite a bit of research behind that now, that often graphics can be distracting. So there was a study done, for instance, where they asked teachers, would kids learn better from bar graphs made of colorful objects stacked up, or gray monochrome bars? The majority of teachers picked the colorful objects, so it turned out kids learned better from the bars. So there's lots of counterintuitive things that why you need to keep testing your ideas.
Harriet, you, as a dean in the School of Education, where you have to prepare teachers, as you were saying, for being in many situations, what are the implications? What interests you about this, and what are the implications?
So I'm going to address, first of all, what I think is good for kids, and then what I think is good for teachers that I see in jump math. I first of all, for kids, see a very good example of guided discovery learning, where there are right and wrong answers, and kids aren't encouraged to just kind of muck around in ways that make them frustrated and perhaps lead in directions which aren't necessarily productive. So I think guided discovery is a really important component. I think what John and his team have done is create practice materials which demonstrate all the principles of good instructional design. They've done a very careful job of sequencing. They've analyzed tasks step by step into manageable bite-sized pieces. They've scaffolded and suggested ways that teachers can support moving from one step to another. They emphasize and identify patterns, and they use visual representations of math concepts. I'm gonna, perhaps because I'm old, I'll say that many of these principles existed when we looked more than 30 years ago at learning disabilities. And we discovered that kids who were then called learning disabled were kids who were instructionally dependent. And many of these principles of practice and instructional design were spelled out at that time. The problem is that it's very hard for an individual teacher to be able to pull that off. As you point out, your team spends hours creating materials. Teachers have, elementary teachers in particular, have hours spent with kids and an incredible number of preps that they're supposed to be able to do to stay on top of all the content areas. So I think they've got to thank you for that. I think you've also done a nice job of adding some what I consider newer thinking, the importance of formative assessment, where you really look at student work. You ask what is called in the field hinge point questions, so you know whether to go to point X or point Y based on kids' answers. And you provide kids with informative feedback, not just check marks, I hope, but also indicating to kids why they got that check mark. For teachers, elementary teachers have historically been individuals who love kids and often love literature and may love reading and may or may not love math. So what you've done for teachers is created a way into pedagogical content knowledge, because it's really embarrassing for me to admit that I don't really understand borrowing, I don't really understand carrying, I don't really understand division of fractions. I can do it, but I don't really understand it. And yet if I work with kids on these tasks, all of a sudden I get it now in a way that perhaps I didn't get it when I was in school. I think there's always the issue and debate around scripts and teacher autonomy. But again, I believe by having very well designed materials, teachers can understand the value of the scripts and scaffolds that they've been given. And the practice materials with bonus and enrichment items are gold for a busy teacher. So that's what I see in Jump Math.
What are the barriers of getting an approach like Jump Math, and in terms of moving it forward or having people, look at this approach more seriously and get it integrated into the education system? What's required to make something like that happen, if indeed people have the same response that you've had? Are there barriers? I mean, are there clear barriers in the system that it's set up to make it hard for an idea to spread and take root like this?
The education system is highly decentralized and fragmented. And I should be clear, I haven't reviewed the thing, I'm not selling a thing. And it's unclear that if I tried to sell something, it would sell, because everybody makes their own decision.
And I'm not even talking about Jump itself, I'm talking about the principles we're talking about here.
So, our strategy at Student Achievement Partners has been to put decision-making tools in people's hands that help them systematically make better decisions. So, but it's frustrating, as I say, it's a highly decentralized system, and there's many publishers all vying, and there are sometimes different ways to skin a cat, and everyone has to decide, and it depends on the training that they offer. It's very complicated. I don't know that anybody has been able to corner the market, and the way publishing has worked is by having very expensive sales forces and blanketing the ground. It hasn't been a mathematical market.
Research-based.
Yeah, or even mathematics-based most of the time.
Very interesting. Well, let's open it up for questions to the group. And questions can be for the panel as a whole or any particular individual.
I'm Lady Rashka from Inside Schools, the website for parents. I'm just curious, I see so many different math programs in different schools, and I'm curious, what's the single biggest departure in your method from, say, Math in Focus or Investigations or?
I think it's a couple things. First, I think if you look at a traditional teacher's guide, you'll see that ours are much more detailed. We provide teachers with Socratic questions, a lot of the assessment they do, because teachers, the research is suggesting they need to assess more continuously. So I think that's one area that's different. And you know, we don't expect people to follow those slavishly. We expect that they're springboards for them to first focus on their teaching, so they can spend their time figuring out which kids need which, how slow or fast they could go, and gradually to eventually develop their own lessons and transcend our very detailed lesson plans. So I think that's one difference. Because we found that there was never, I don't know, I think it's the same here, but in Canada there was never enough professional development money to not only help teachers understand the math more deeply, but also know when to assess, know how to connect concepts and all those things. So that's why we made such detailed guides. The second thing I think is in the, the Common Core standards are based on rigor and coherence, and we think that's very important. So I could give you one example. A lot of programs in grade 5, they teach decimal expansions, which is in the Common Core standards, very early in the year. So 0.7 is 7 times a tenth. Well, what's involved in that? You have to know how to multiply a whole number by a fraction. You have to know how to add if you're doing a big decimal expansion. And even though kids saw that in grade 4, many kids would have forgotten it over the summer. If they're transitioning to the Common Core, they may never have seen it. So we purposely only dealt with whole number place value first, and then later, after kids had good exposure to fractions, we did decimal expansion. Because otherwise it's magic, and it's just giving kids the impression that math is magic, which is the last thing we want to do. You know, as a mathematician, logicians proved 100 years ago that all math can be reduced to very sensible, easy steps, and we think that's a right of every child to know that, and every teacher to know that. So that's why we wrote, we hope, rigorous, coherent, and very detailed lesson plans. You can ask challenging questions too.
I asked you this question privately. You talked about the components of the curriculum, and also it was clear watching your lesson, there's a joy in the pedagogy that you bring to it. Can you talk about how JUMP kind of builds that pedagogical part?
Yeah, and that's a good question. And you know, we're a fairly small charity, and we're wrestling with that all the time. And as we grow, we're hoping to get better and better at helping teachers deliver the program. We thought the starting point was giving them extraordinarily detailed lessons, but then knowing how to play with those lessons, knowing how to you know, make the kids feel like they're meeting a series of harder and harder challenges, that's a performance aspect almost. And I started volunteering in inner city schools 15 years ago, and I'm a playwright also, so when I went into the classrooms, I thought these kids are an audience. And you know, people never get more excited than when they feel things together as an audience. And what destroys that effect are the hierarchies. If you have kids all over the map and only some are succeeding, you have no audience effect. Durkheim called it collective effervescence, this incredible joy that bubbles up when everyone's solving something together. And so that's an area where we're working now. We're videotaping master teachers. We're working with the University of Calgary. They've been helping us understand what teachers need to use the program well. You know, how they can get practice raising the bar and making the kids feel more and more excited. That's the part now that we finished the materials that we're going to invest in more and more. And that's why we're so excited to be working with CUNY, because we can learn a lot, and because they have I met many of Nikki's staff, and they have an amazing team who are very well trusted in New York schools. So we hope we can learn a lot from that and really multiply our effect through partnerships like that.
David, can I raise an issue that you asked me what the conundrum is for me? And the conundrum for me is that, you know, everybody turns around and says, why didn't they know this if you gave them a teaching certificate or you recommended them for a teaching certificate. And the people who ask that question most frequently are teachers themselves, right? Why wasn't I prepared to do X, Y, or Z? And so whenever I look at a very well-constructed program, there's a temptation to say, well, and this has happened in the past in teacher preparation, you're only going to be trained on whole language because that's what we believe in, and phonics is out. Whoops! 5 years later, phonics is in, and you're only going to be trained on a systematic, sequential approach to word recognition.
But Nikki, fractions are forever.
No, I get, but approaches.
Not the
are-
way you do them.
I think the key here is that it becomes trying to figure out how you can, as you point, scaffold, okay? What is it that a beginning teacher absolutely needs to have before they get out? And do we have the ability to make sure that they've got it versus what should we be doing once they're already in the field? And mainly this program has been working once teachers are already out there. And perhaps you can address that
Yeah.
issue. What did you not
I was
know?
thinking about every
Yeah.
year.
Right, could we have done it or were you simply not ready?
Yeah, I don't think so. I don't know, because I feel like everything I learned is by doing. So, I mean, and I've been doing it for a while. So, I feel like every year you notice things different than that you didn't notice the year before. You have different challenges one year than you didn't the other year. Like this year, I learned that we were doing fractions, and it was the word problem was they were making a cake. And that children didn't understand that when you poured the oil in the cup and then you used it, it was gone. They didn't know, and I said, well, haven't you made a cake with your parents? Haven't you made? Because I did that when I was, when I was younger, and they said no. So I learned that you don't know. I mean, every year is different. Every month, every day is different. What the battles you're gonna have. So, so I don't. I mean, you can't prepare for everything. You just can't. But I think when something comes along that, you should definitely try new things.
And what would be the ongoing sort of learning process, given what you've just said, while in school? Like, how would this get reinforced in service rather than pre-service? I'm using your terms.
Yeah, you're fast.
Professional development for me as the
Like
now.
Let's say there's a couple of teachers in a school who found something that, some principles that are really making them feel successful. How does that then get into the DNA of the school as a whole? Like how might that happen?
Well, you would work with, I work with a partner, the other fourth grade teacher, so she and I collaborate.
Yeah.
We're very close with third through fifth because we're the testing grade, so if something works, we share that information. It just depends on the school. I mean, I've worked in schools where it's different. They're bigger, so you don't have as much interaction with all the teachers. The school is smaller, so you do have more interaction, so we can talk. We also have a consultant that comes in and gives us information and then shares it with all the other teachers. But if you have it depends though also on the teacher. If you have some sort of keep it in, they learn something and they, it's like theirs.
So just to get, because there is something that you were saying, like it's pretty much all been while I was teaching. So what is the pre-service, it sounds like, what is the pre-service component of this? The part that could be helpful before, acknowledging that most of it is.
Yeah, I just think student teaching, when you have to throw them out there and have them see it and talk to teachers. I mean, that's where I learned the most was when I student taught. I still know who that person is and remember things that, you just learn. Even just your interaction with the children is a whole thing. You can't teach that. You have to have, some presence with them that they trust you. So I don't know how you would teach it. I mean, I don't have the answer to that question.
I don't think anyone.
I'll just point, in the February Notices of the American Mathematical Society, I have an editorial that touches on this, and I tried to, in there, amplify longstanding recommendations by mathematicians in education about courses that could be required courses of future elementary teachers. And so if you ever want the link to that, I can share it around. But maybe you're the person I should say.
Yeah, no, I think I've read those links. Again, the question is, and some, I think as I recall, there were 4 or 5 courses in math that were recommended. And now I sort of look and say, okay, if we're going to make teacher preparation 8 years long, we've got to wait. This will work. But
one course was my recommendation, but I'll send you the link.
Okay.
But what happens often, and this happens because of math departments often at the university level, they say, well, this is a university, and it's going to look a little weird if we are teaching people fractions.
Right.
And so to discover what is profound in fractions mathematically and to have a college level experience for future teachers in the mathematics of elementary school is something that doesn't happen often enough. You can find it in certain places.
I had that same experience with John once when I was, when I was interviewing him for the article that I wrote. I asked him, I said, so why is it that when you want to divide by a fraction, you flip it and multiply? I mean, just, can you explain that to me? And he took me through it in about 10 minutes, and it was one of those exciting moments when you're like, oh, that totally makes sense. But it was going away from a magical idea of like, I know this works, to really seeing, the 4 steps that makes it clear.
Yeah, and it's such an important issue. Teachers are my absolute heroes. They've been responsible for the growth of JUMP. They've been willing to experiment and try things and advocate for the program, even when they were discouraged from doing so in Canada. And we've grown exponentially in Canada because of teachers. But as Nikki pointed out, many teachers will admit that they don't love math or know it deeply. So at the Calgary Teachers Convention, I asked about 700 teachers why, when you divide 7 by 2/3, you're allowed to flip and multiply. And someone yelled out, because you got the right answer. Unfortunately, that wasn't really a joke, because I've surveyed hundreds and hundreds of teachers, and if they have an explanation, it usually involves multiplying both of the terms in the division by a fraction, like a reciprocal, if you remember that term. They don't notice that just pushes the problem somewhere else, because now you have to explain multiplication by fraction, which is equally mysterious to most adults. And I've only met a handful of teachers who can give me a really simple explanation. I usually use a chocolate bar. It's very easy to see if you take a concrete object, and you can see immediately why 6 divided by half is 12 if you just show it with a model. And teachers are always shocked, and they say, why don't we know this? And so you have an army of teachers teaching this to kids without deep understanding, or the excitement that they get when they actually figure out how it works. I mean, teachers get as excited as the kids do. That's a tragedy. I mean, that's just, how can we, it shows the depth of our inertia, the depth of our beliefs about ability, how fixed our mindsets are, that we can have an entire society that perpetuates this idea year after year that the division of fractions, which is trivial and I could show you in 10 minutes, it's absolutely trivial and I could show you in 10 minutes, is this mystery to the vast majority of people. And imagine not only the economic loss. I mean, there are studies that suggest that these deficits cause an equivalent of a permanent national recession. There's also studies that show that math is a far stronger predictor of long-term academic success for young kids than even reading. And the biggest loss for me is this loss of a sense of wonder and curiosity. I don't know if the people who saw that demo lesson saw it in the kids. Kids are willing to spend hours solving puzzles and seeing patterns and making connections. And they lose that sense of wonder and curiosity through failure and by comparing themselves to other kids and thinking, I can't do this. That's the biggest tragedy, far more than the economic loss, is a loss of wonder and curiosity and a kind of way of engaging with the world that's as important as looking at a beautiful mountain. We should also see the invisible beauty of the world, and that's the birthright of kids.
Can I add on to this answer?
Sure.
Just to point out
have a
that,
question there.
sure, I'll be fast to allow it. When we were designing the standards, the governors and the state superintendents asked us for a product that would be world-class. So we looked at high-performing countries. They asked us for a product that would prepare kids for post-secondary learning experiences in mathematics. We looked at the evidence of college readiness, and that's raising the bar. Both of those things have led us to raise the bar, and so just teaching invert and multiply, I'm certainly not going to hide that from students. I want them to be able to find quotients, right? But if every single problem is a mnemonic or a lookup, so like, okay, I see this kind of problem, I do this thing. I see this kind of problem, I do this thing. And then I'm teaching that way, and all that's in the kid's brain is a database of problem type, solution method. And I just hope they remember when the test day comes, where that problem is in their database, and they'll remember the thing. That turns out not to work, because there are too many kinds of problems in math. And so we need concepts to become powerful in mathematics and to have achievement in mathematics. And so that raises all these questions about small jumps and skinny concepts, as another colleague of mine puts it. So it makes them urgent in a system where we're actually asking to raise standards.
And a skinny concept is a?
Oh, it's another math educator of mine. It's a similar metaphor to a small jump. You know, it's something manageable, and by you know, there's something kind of nutty about some of the constructivist stuff you say, that is as if, you know, a kid is going to invent the place value system or something. But you know, you bring the terminals very close together, then a spark can jump across them. That's how I picture something.
And if you have skinny concepts, you can see, oh, this is where the error is occurring. It's at step, micro step 2 instead of, right.
And they figure out we had that situation where it was multiplying fractions. It was like a fourth of 60. And then after we went through the lesson, one of the students said, but couldn't you just divide that and then multiply the numerator? And yeah, but it showed that he knew what he was doing.
You pull it out of them and show it back.
He figured it out. I didn't show him. He knew that.
Yeah. That's great, David.
Sure. It was interesting what you said, John, about kids making comparisons with each other and trying to minimize that. And it made me think about when I was in teacher training about 9 years ago. It was all about differentiation and giving students different things. So like the student in the front that was doing really well should almost had a different lesson than anybody else. In some ways, people talked about differentiation.
Yeah, so that's a really deep question. We like to think that you can do differentiated instruction without differentiated outcomes. And in David's article, the original article, there was a case study of a teacher who had a grade 5 class where there was a 70-point range of marks on standardized tests between the bottom and the top kids in the class. Average mark in the 54th percentile. A year later, the average mark was in the 98th percentile with the lowest in the 95th. So she didn't hold anyone back. She didn't give every kid exactly the same question all the time, especially at the beginning of the year when she barely knew the kids. But eventually, the outcomes were roughly the same for all kids. So you can differentiate, but people differentiate too much, and they produce hierarchies, they produce different outcomes for different kids. And that lesson I did, I made tons of mistakes. So I wasn't well enough prepared, I didn't know the kids well enough. I managed to keep them roughly together, but there were 3 or 4 kids that I would have worked with before the lesson. And I would have had a more careful continuum of problems. I didn't have a foolproof set of problems, but they got so excited I kind of just went with it.
He always wants to zoom in between any 2 points.
Yeah, I always need to know what's between, but in that lesson I didn't, and so I lost a few kids. And I would have, if I knew them, I would have prepped them beforehand, and I would have had some extra questions for them. The idea is there's a theory of education called variation theory that suggests that if you can vary different elements of a problem, you just vary one thing at a time, let kids figure that out, discover it, consolidate the knowledge, then vary a second thing, and then gradually as they become more confident, vary many things. Now that's what I did in that lesson. By the end I was varying too many things at once. But the kids were so excited, I wanted to leave them with some challenges. But I would have, if I had known the kids, spent more time with the ones who were at the bottom. Because the teacher in David's article, in the case study, it took her a year to get a couple of the very lowest kids to the point where they were always excited and engaged. It can take a while and it can take a lot of extra work. But she produced those results by making them feel they were roughly equal and doing the same things. She told them about how their brains work, that, you know, some of you may take longer. I always tell kids I'm not a fast mathematician. It takes me a long time to work on things. She gave them permission to struggle, to work, and in the end, the weakest kids were outperforming what the strongest kids were previously doing. So again, it's differentiation without differentiated outcomes. I hope that makes some sense. It has to do with the size of the variation, and we think most teachers vary too many things, and that creates the hierarchies, the discouragement. And we found faster kids don't generally get bored by those variations. You can always create something that looks harder but isn't a new topic.
The implications that you said were that when you introduce these bonus questions or these challenge questions, you're not actually introducing new material, so you don't have to spend all that extra time with the kids who are getting the challenge questions. You can still focus on the other kids.
Yeah. So to give an example, in that class where I made mistakes, I gave them problems where there were letters standing for numbers, and I didn't spend enough time having them understand when two letters stood for different numbers. You really had to do some thinking and experimenting. You couldn't just plug in the same number, and I went way too fast over that. But that's what I mean about I just varied too many things in that lesson.
And he got a D the first time he took calculus. Yeah. Luckily, it was belled to a C.
So. Yeah, I passed because of the bell curve.
That's it? Okay.
One more question?
One more question, or?
I have.
Yeah. Okay.
I'm a former Montessori teacher, and I had a lot of these aha light bulb moments in my Montessori training in math, like what a cube, squares and cubes of numbers, because they physically show you.
Right.
I'm like, oh.
Right.
So I just wondered if you know about Montessori math, and it also does increments of learning and a lot of visuals and beads and colors, and it keeps kids on those things longer. So I just wondered if sometimes I feel like a lot of these, it's one thing I loved that was embedded in your lesson was all the talk around the trusting atmosphere in the room,
right.
Saying
right.
This is a struggle, I'm making mistakes, and I wondered if you know about Montessori and...
A little bit, not enough, but I admire what I know. And we've even talked to some Montessori schools about maybe partnering, but we're just so short-staffed that every time it would kill our staff to even suggest things like that. So, but it's something we'd like to explore. There is an interesting new body of research called concreteness fading that teachers need to know about, because it turns out that kids at an earlier age need to start moving from the concrete to more abstract models, like a number line representing something, or just instead of drawing the details of a picture, just a square could represent something. They need to move there more quickly and rigorously than people previously thought.
I was reading that research.
Otherwise, they get too caught up in the details and of the materials, and they don't learn to generalize or develop mental models.
Yeah.
So that's we've been looking at that research and trying to take account of it in our books.
Yeah.
Well, thanks very much. I'll just conclude with something that you said, John, when we were in the story. That it's a quote, but it's not actually a quote because it's not exact. But it was something like, "I've never met a teacher that disbelieved the idea that kids can't succeed unless they have confidence. But I haven't seen too many curriculums that actually take that insight and apply it rigorously, and that's what they're really trying to do, is really to take the insight that confidence is necessary. You need to scaffold love, basically, teaching through the heart, and that's what really struck me about this approach, that it's really trying to do that, and so that's why I wrote about it. So thank you very much.
Thank you. Thank you so much.
Oh yeah.
I'd like to introduce Andrea Johnson. She's the head of U.S. Financial Education at CUNY Bank, one of JUMMAC's oldest and most generous supporters in Canada, and we're excited to have your support here in the U.S.
Thank you so much. So I wanted to take a moment and point out a few words that I heard kind of jump out at me during this discussion, and thank the panel for this really engaged discussion. So mindset, joy, confidence, those are all things that we think about at TD Bank. My name is Andrea Johnson. I lead our efforts in financial education, which is definitely an applied math topic. And getting more adults confident in their math skills is absolutely critical for what we do in financial education. And the economy has changed, the landscape has changed so significantly with personal finances. Think about generationally what has happened since Gen X and Gen Z. I mean, it was World Book encyclopedias then, and now it's wikis, the way that we're learning. So we're trying to evolve financial education, and we consider math a very critical skill for kids to have and grow into adults that can actually manage their personal finances. So we appreciate Jump Math, and we're glad and very proud to sponsor Jump Math in these efforts. And we've given a significant amount of money, $100,000, you know, to fund this study. Because we think it's so incredibly important. I mean, think about the impact of compound interest to someone's savings or to someone's debt. It can have a significant impact on their day-to-day lives. We take financial education very seriously at TD Bank, and we have had over 20 years of experience of teaching children in schools, and we're also moving into the digital space as well and teaching adults some of these concepts. And their ability in math, when we come into a classroom, and we teach from kindergarten through 12th grade in public schools and all types of schools, but when we go into a classroom, and many times it is a math classroom, that confidence has to be there so we can teach them things like interest, and then make it, and then also when advanced skills like loan payments and budgeting, when we get into, you know, some more, and sometimes budgeting can be very, very hard to do those maths because sometimes you end up in a negative. So we're very, very proud to do this, and we just want to thank the panel for all of their great work. Obviously, thank you, Jump Math, for all of your good work. And we're looking forward to the future. We also provide teacher resources on tdbank.com/wowzone. We provide lesson plans, so if anyone's looking for practical application in their classroom. We also have educational platform for adults at tdbank.com/financial education. We'll be adding more to that platform. And these math skills, you should be proud of what you're doing, because it's not just helping people with these concepts of math, it's critical life skills for sometimes people's #1 priority, which is their money.
So we appreciate the support that allowed us to come here. Seal Daniels is here from Johns Hopkins, and she was actually part of the study and she observed the classrooms using Jump, and then was so excited that she's helping us now develop our training. So that was made possible through the study, and we want to thank especially the school. This has been such an inspiring experience for us to have to work with such a dedicated group of teachers and consultants at the back, math coaches too, and administrators. So thank you so much.
Thank you, everybody, and thank you to the
So our demo lesson is starting shortly.